Hello. It's just a sound check. This is a sound check. I'm just doing an audio test because I think there's an echo. So just give me a few minutes. Hopefully I'll resolve it. Is this better? No. Okay, I think, is it still echoing? Yeah, because iPad is echoing. Okay. I'm sorry, but this is going to take a few minutes.
Is this better? Okay, I'm not able to disconnect audio from the iPad. Okay, so we can start like this, and I'll figure out how to connect the audio from iPad in the meantime. Okay, let me share the screen for today. But before I go ahead, anybody had any questions? Yes, go ahead. You can type your question, or if you want, you can unmute and speak here itself. Yes, please go ahead if you have a question. Somebody said yes in the chat, so okay, I'm assuming no questions. Okay, why does variable cost progressively increase when producing more units? Okay, this shouldn't it produce due to economies of scale? So I think you're jumping ahead a little bit, and economies of scale is something we will talk about in some detail a little bit later. But uh, just from just from basic simple logic, why do you think variable cost would increase? Anybody wants to attempt the answer? So I think the chat is visible to everybody, right? So if anyone wants to try answering this his question, you can take a shot. Due to diminishing returns, he's talking about cost, not and reaching max capacity. Wait a minute, what are you asking exactly? Sir said due to diminishing returns and reaching max capacity. Okay, I'm not sure exactly which part of the lecture you are referring to. Um, yeah, he's talking about variable cost. I can give the answer. I just wanted other people to think a little bit first. No, that's not what I'm asking. You're not answering what he's asking. He's not asking about the types of costs. He's asking about variable cost, and he's asking why is the variable cost increasing? Okay, so it's increase in products. So what is the variable cost? The variable cost is the cost which is varying with the quantity, right? So if you're increasing more and more quantity, not only are you using more and more say raw material, but you're also using more and more other resources, like maybe labor, like maybe some other technology which you want to use to improve your production processes or something. That's why we are saying that the variable cost is going to increase. We'll come to this, what you're asking, economies of scale. We'll talk about that. That is not exactly what economies of scale refers to. Um, we've not really talked about any production function so far, right? We've only talked about supply curve. That's why I keep asking you to not jump ahead, because if you start mixing, um, yes, I will discuss that. I'm just trying to understand what people are asking right now, what doubts you guys have. I will talk about price control and surplus. Just to answer his question first, the economies of scale is something we will discuss much later in the course, and there's a reason for that. That is because you have not studied the production function right now. You've not done producer theory right now. So how we compute economies of scale, what it means, we'll come to later. What we're talking about right now is just the variable cost. Don't mix the concepts, otherwise you will confuse yourself. That's the reason why even last time some people were asking about utility and opportunity cost, and all those terms mean something very different in economics. So if you mix all those terms, you will get confused. Just stick with what this week's material is. I know it's exciting to jump ahead, but try to not mix those concepts because they're two different concepts. Okay, variable cost increases because in general, like if you're making one notebook, you need some amount of raw material. If you make 5 notebooks, you need more raw material, right? That is what variable cost is. Fixed cost is just cost like the rent of a room. Okay, you're paying some rent on, say, some machinery or some manufacturing space, that is fixed. You're paying that irrespective of how many units you manufacture. But when you start manufacturing units in higher quantity, you're definitely using more raw material, right? Plus, say suppose you need only one person to manufacture 100 notebooks. Now for 200 notebooks, maybe you need to hire one more person, right? So generally you will observe that variable cost will keep increasing. No, it will not remain uniform. That's what I'm telling you. You have to listen to what I'm saying. You are increasing other costs also. You're only thinking of raw material now, because I started talking about raw material. When you're manufacturing say 100 notebooks, you're using some amount of raw material, right? When you're manufacturing 200 notebooks, maybe the raw material amount increases proportionately, but you also need more labor. Just raw material by itself will not get manufactured. You need more people to manufacture it also, so you're increasing your costs a lot more. So it increases because there are many components which keep coming into play when you increase the quantity. In general, when we talk about long run cost and short run cost, and when we talk about the production function, these concepts will probably iron themselves out about how you can decrease your costs in the long run, and how you can achieve efficiency, and how you can achieve economies of scale. But right now, this is, I think, what you should stick with, because this is the basic economics of cost. No, he's not mixing marginal cost and variable cost. He's saying that variable cost is why should it increase with quantity? The variable cost is increasing with quantity because it is based on quantity. It is not going to decrease with quantity, right? It can remain the same, but it will not decrease with quantity. So understanding, variable cost is a function of Q. So it can be Q square plus 2Q, it can be 5Q. It is not going to be minus 2Q. You understanding what I'm saying? Marginal cost can increase or decrease. That depends on where you are in the how much your quantity is or where you are in this marginal cost curve. This the marginal cost curve is like something like that. So it can increase or it can decrease. But the variable cost is only going to increase. The rate at which it increases, at the rate at which it remains, it may remain same, or the rate at which it increases may decrease. I think that is the part where you are probably confused. Is that so? Yes, so the rate of increase may decrease, but it will still increase. If you're using, yes, you're not asking about rate of variable cost increase, though. You ask why should it increase? So it's always going to increase. The rate of increase will change, but the variable cost itself will definitely increase. Okay, because obviously if you're using say a certain amount of quantity for of materials for manufacturing, say like I said 100 notebooks, you are definitely going to use a whole lot more than that for 200 notebooks. The cost will increase. The rate at which it increases is all about how you manage your costs. You will obviously do everything you can to keep the rate of increase low, and please don't mix it with the other concepts because that will not help. Okay, so let me share today's um, slides. Okay, can you see my screen? Total variable cost increasing. Yes, so okay, all right. So let's. Uh, okay, so this is the first question. You have a market demand curve for a good, and this is the market supply curve for the same good. And first, before we talk about any price ceiling or price floors, let's just go with the equilibrium price and quantity first. So I'll give you a few minutes to solve the question, and after that I will solve it, or you can just tell me the answer. It's simple enough here. Others, only one person has answered. You can still see my screen, right? Okay, great. I was just unsure if I got disconnected. So I hope there's no echo now. There is still an echo. Okay.
Okay, is this better? Are you still getting an echo? Okay, thank God, finally. Okay, so let's solve the question. Okay, let me share from here. Am I audible? Okay, I think you can see my screen now. All right, so let's see the question. The market demand for a good is X. For good X is, let me write this down. Question 1. Px is equal to 2000 minus 4Q. And the market supply is Px. Now, because the first one is demand, I'm just labeling this as QD. Just for clarity, it will be useful later. In this part of the question, it's not that useful, but this is the supply curve. Okay. So what we want to do is, first of all, we want to find out the equilibrium price and quantity. So in equilibrium, basically markets are clearing, right? That's what equilibrium is defined as. That's what equilibrium means, that there is only one market price and the supply and demand are equal to each other, right? So you have no excess and no shortages, and there is only one price, and that is the equilibrium price as per the demand curve and as per the supply curve. So either you can solve it by equating the price, or you can solve it by equating the quantity. So you can, in this case, just simply equate this 1000 minus 4Q. Now I'm just bringing it back to Q because or Q star, because in equilibrium, let's say, let's call this Q star and this is P star. Okay, so 2000 minus 4 Q star is equal to 300 plus 6. Sorry, Q star. Now you can simplify this whichever way you like. 10 Q star is equal to 2000 minus 300. 100 Q star is equal to 170. Okay. Now similarly, you can compute price also. Price is just plug in this value, and in either of the equations, you can do it in either equation. So let's say 2000 minus 4 into 170. I have solved this somewhere, I think. Yeah, I'm not solving it right now. You can just do the maths. This comes out to be 1320 as far as I know. Okay, so did anybody else get the same answer? One person posted, Arnav Bansal posted the answer. So other people, everyone else, is this able to follow? This is hopefully not too difficult. So far, we have not imposed any kind of price controls or quantity controls. So far, it is only just equilibrium, supply and demand. Okay, so now let's go to the second question. This so this is, let me see if I can annotate this. Okay, still doesn't work. So this is A. All right. Next, let's go to the market demand curve for good X is this. And what is the consumer surplus before price ceiling? So what do we define consumer surplus as? Let's first draw this in a diagram. Okay. This is your demand curve. This is your supply curve. And let me draw it here. This is Q. This is P. And this is say 2000. And this is say okay, this is demand curve. And this is 2000. Trying to make it a bit proportional, but it may not be completely proportional. So this is your supply curve. Okay, and the price we have computed, which is here. This is P star, which is 1320. Okay, so the diagram is again not exactly to scale, but I think you sort of get an idea of what I'm talking about. This is 170. Okay, so now in this diagram, let's first shade what is consumer supply, consumer surplus and producer surplus. So what is consumer surplus? What did we discuss last time? We discussed this in the class last time. And of course, it's there in the lecture videos, but how do we define consumer surplus? Somebody wants to answer? Consumer surpluses? Yes, it's the maximum willingness to pay minus the market price, equilibrium price, you can say, if it is in equilibrium. If it is not in equilibrium, then just the market price. Okay, so what does the demand curve show? Demand curve kind of represents your maximum willingness to pay at some point, isn't it? So this is, say, suppose for the 0 plus 1th good, maybe your maximum willingness to pay is 2000. Then it keeps on decreasing until in equilibrium for 170 units, your maximum willingness to pay is only 1320, right? So at the 170th quantity or 170th unit, your consumer surplus is 0. But your all the previous units, first, second, third, fourth, so on and so forth, you are making some positive consumer surplus, right? So let me draw it here. So this is the price which is in the market, 1320, and the demand curve is in a way showing the maximum you are willing to pay for it, right? So this diagram, I've shaded that pink area. I hope everybody can see that. This is your consumer surplus. So is this making sense? For the first unit, consumer surplus will be, say, 1 into something around 2000, little less than 2000 maybe. You can read it from the diagram. You can put Q is equal to 1 in the diagram, in the equation for demand, and see what it is. It's 2000 minus 4. What is that? 1996, something like that. I'm just doing this calculation to help you understand what we are really trying to do in the diagram. Okay, I'm talking about first unit, second unit like that, but this is actually a continuous curve. So it's not going to be a step function. This will be an integral, or basically an area of this triangle, because you're taking the cumulative consumer surplus. So there is a consumer who is willing to pay something like 1996 rupees for the first unit. Then there is a consumer who is willing to pay something like, less than that. So we are taking a cumulative of that whole thing, and that cumulative becomes the area of this circle. Is this okay with everyone? Because nobody was answering, so I'm not sure if this part is clear to everybody.
Yes, ma'am, it's clear.
Okay, I'm not wearing my earphones. Sorry if you said something, because I can hear myself in my earphones. So yes, yeah. Sorry, anybody was saying something? Okay, it's clear. Okay, so I'm hoping people who have not answered also, it's okay with you. So moving ahead now, what is producer surplus? Similarly, producer surplus is the the difference between the marginal cost and the price at which the producer is selling it. And it is, in a way, it is a little more concrete. It's very because valuation is something like we have said, maximum willingness to pay. But when it comes to producer, we know exactly what the marginal cost is, right? We have computed it. So, and what is that? Marginal cost is nothing but the supply curve. Supply curve is the marginal cost curve, basically, right? So what we want to compute is basically the marginal cost and the price and the difference between that. So a producer will only sell as long as the marginal cost is less than or equal to price, market price. And in this case, we know the market price is 1320. So for all the units before that, the marginal cost is lesser than this price. And this area which I've shaded on the diagram, this is your producer surplus. I'm going a bit slow in this part because I think this is like a bit important. So I have not calculated it right now. Let me see, I may have calculated it before, but this is how you compute it. I don't think I've calculated it in my notes, but this is the method. So if you want, you can just calculate it. This is the consumer surplus. So let's do this. Some other color. Okay, so let's do the second part. Consumer surplus is equal to half into 170 into, this is what, 2000 minus 1320. So whatever this comes out to be, you can do the calculation. I've just read the triangle, just taken the area of the triangle. Similarly, producer surplus is this blue, light blue color triangle. This is half into, again, 170 into 1320 minus 300. and total surplus is consumer surplus plus producer surplus. So this is the way you compute it. You can just do the arithmetic. If anybody has solved it, please tell me what the answer came out to be. I can solve it right now. I think I have it somewhere. 1 minute. Has anybody computed this? Did anybody get the answer? Okay, so I think the consumer surplus is 57,800, which is what? What is the answer? Which option is that? The option C. I think consumer surplus comes out to be 57,800, and the producer surplus comes out to be 86,700, which is okay. They've not asked producer surplus, so I'm not discussing it, but that is what it comes out to be, 86,700, and you can calculate the total surplus. Did other people also get this answer? This is before the price ceiling. I just found the answer from before. I've not done it right now. Let me check this. Somebody is getting some other answer, right? No. So you have what you've made, the mistake you've made in producer surplus is you have only taken the difference between the market price and the marginal cost. You have forgotten to multiply it with the half base into height thing. You've only taken, okay, so you got the answer now? No, you're getting the wrong answer for producer surplus. I'm wondering what you're doing. Producer surplus is 86,700 and consumer surplus is 37,800. So you got the consumer surplus right. See, this is producer surplus. You take this as the base of the triangle, and this is the height of the triangle. Then you do half base into height. I'm just reading the responses and replying. Okay, I think we've spent a fair bit of time on this. I'll move on to the next part of the question, which is the more important part actually. So now let's talk about the price ceiling. In the price ceiling, we have, what is the price ceiling? Price ceiling is when you can't increase the price beyond a certain amount, right? Isn't it going full screen? Anyway, it's okay. So what happens in the case of a price ceiling? What we are saying is that there was already an equilibrium price, and now in this particular question, we are seeing that the price ceiling is much lower than the price which we had before, the market price. Price ceiling is, see, if the price ceiling is above the market price, then nothing will happen. Is this much clear to everybody? Because if we are saying that the highest value you can achieve is already much higher than what you are getting in equilibrium, there is no change in the market. Only change is going to happen when the market price is higher than your price ceiling. Okay, so in this case, we have a price ceiling somewhere here. Okay, I'm labeling this as PC and this is 500. Okay, so you can see my diagram is again a little bit, little hodgepodge, but it's still neat enough. So you can see that the price ceiling is below 1320, which is the market price. Okay, so what happens in the case of a price ceiling? There is some difference between market supply and market demand. They're both not going to be the same because there is only one price at which market supply and market demand are exactly equal to each other, and that is the equilibrium price, which we already got as 1320. At any other price, if the producer is forced to sell at any other price other than the equilibrium price, there is going to be a difference between the market demand and the market supply, because the buyer is willing to buy at a certain price. So if the price is brought down at 500, of course buyers are willing to buy at that price, but the producer is not willing to sell the same quantity at that price. And what is the producer willing to sell? Producer is willing to sell some lower quantity, this. And what is the consumer willing to buy? Consumer is willing to buy this quantity. So the place where this price ceiling line is intersecting the demand curve is the new demand, QD prime. And the place where the price ceiling is intersecting the supply curve is the new supply, QS prime. So now we know that there is a difference in the supply and the demand, right? So this is now simple enough to compute. All we want to know is the values of QS prime and QD prime. And what will we do? For that, we have these two equations in the beginning, in which I wrote QD and QS just to differentiate. Let me not put this here, it's kind of confusing. Let's say P star and quantity Q star. Okay, so the first part where I've written the equations, this is the demand equation and this is the supply equation. Now in these equations, you plug in the value of price, which is now 500, that's the price ceiling price, so that is forced to be the market price, and you find out the value of QD and the value of QS. Now that difference in QD and QS is what is going to be, is there going to be a shortfall, or is there going to be an excess supply? Which one do you think it's going to be? Does anybody want to answer? What happens in a price ceiling? Is there a shortfall or is there an excess of supply? What's going to happen? We just kind of discussed it, so it's not so difficult. Yes, it's going to be a shortfall, because like I was saying, like, if the price is lowered, the supply is going to reduce, right? Because the producers don't want to sell so much at that price. The price at which the producers want to sell so much is the equilibrium price. Q is equal to 170 is the equilibrium quantity, which is what the consumers are demanding at that price. And in equilibrium, and only in equilibrium, consumers are also willing to buy that much quantity at that much price, and producers are also willing to sell that much quantity at that much price. At any other price, there is going to be a difference between how much quantity the producers want to sell at that price and how much quantity the consumers want to buy at that price. So now in this case, let's see what that difference is. So let's compute this. Has anybody computed this already? Okay, somebody has computed. Great. So what is the quantity being traded in the market? Did anybody get the answer? Okay, I think two people have got the answer, so that's good. Others? See, when you're asked what is the quantity being traded, it will have to be the quantity being supplied, right? Because only what is supplied can be traded. The consumers can demand whatever they want, but they eventually have to buy only what is available, right? That happens so many times. You have an onion shortfall, you have this shortfall, and that may not be because of price ceiling, but the quantity traded is always going to be the quantity which is supplied. Okay, so let's compute QS prime first. So P is 500. This is the part is equal to 300 plus 6 QS. I'm putting QS prime because this is not the new quantity. QS prime is equal to 200 by. Okay, so this is straightforward, right? And let's calculate the QD prime also, because that's what the next question asks. 2000 minus 4. You can calculate whatever that comes out to be. So I think 375 or something. Yeah, somebody's calculated it. Okay, so now you can see, like just in numbers, you can see that there is a huge difference between the quantity supplied and the quantity demanded. Therefore, you can calculate the shortfall. And let me see what this comes out to be. This is okay. So I think this is pretty straightforward now. If you know the method, you can always figure out these things. Is anybody having any other questions on this? Somebody wanted to discuss this in today's class. So is it clear? You had asked something. Effects of price control.
That was a bit confusing.
Yes. Which part is confusing?
The producer surplus part on the graph was a bit confusing. If you could just breeze through it once, it would be great.
Okay. So, supply curve is the same as the marginal cost curve. Is that much clear to you?
Yes, ma'am.
Okay. So now you see in the curve, you see this diagram. Let me make this a bit bigger. In this diagram, the supply curve, let me make it in another color if that helps. So this is the supply curve. This is the marginal cost based on, every unit which is being sold. You can read the marginal cost for every unit of quantity sold from this curve. The price which we have initially in equilibrium is this thick white line. This is your price. This is P star. And this is your price, ceiling price, P. Right? Now, the producer surplus is just the difference between the market price and the marginal cost, because that is basically the profit that the producer is making on every unit he's selling, right? So initially, when the price was P star, what is happening? This was the whole region which was in surplus. Let me shade it like this region, right? Because this is the whole summation of on every unit he's making a certain amount of profit, and it's not the same for every unit, right? It's changing with every unit because the marginal cost curve is changing with every unit. And I can draw it as a step function, but in this particular question it's a straight line. It's not a step function. So if you see it like this, if I make it a little bigger, this is the supply curve. This is, say, the price P star, and this is new price P C. This is, say, suppose the equilibrium. This is the demand curve, and this is the price ceiling. So it's here. So initially, this whole region will be the surplus, right? because you're going to take an area of this triangle to compute for every unit. Its unit is this much. First unit, it is maybe this much, then it is this, then it is this, then it is this. So on every unit, you are making a certain profit, which is the difference between the marginal cost and the price. So when you want to calculate the total producer surplus, you take the entire area of this triangle, because this is a continuous function. It is not a step function, right? So you can't calculate one unit like that. You have to take if it's some other curve, you can take an integral, but in this case, it's just straight line. So that makes our life easier. We can just take the area of the triangle. Is this making sense?
Yes, ma'am.
It's just a summation of the kind of, you can say, the profit the producer is making on each unit, right? And when we want to take it for 170 units, this is 170 is equal to Q star. And this is not after price ceiling, this is before price ceiling. After price ceiling, you have this new price PC, and this is the only producer surplus after price ceiling, because this is a new difference between the price and the supply. The supply itself has reduced after reduction of price because the producer is not willing to supply that much. So this is the new supply, QS prime, and the difference between your marginal cost and the market price is also reducing because market price is PC. So now this region is the only surplus the producer is getting. So basically, price ceiling control is reducing the producer surplus, and it is also going to reduce consumer surplus. I've not discussed this, but if you do a similar calculation, we will see that consumer surplus is decreasing. You can do the calculation, but even from this common sense, you can understand that the consumer was initially buying 170 units. Now he is buying much smaller quantity, QD, which is 33 units or something. And even though the price has decreased, the total surplus of the consumer is still going to be less than the initial amount. Is this clear?
Yes, ma'am.
Okay, great. So let me go to the next question. We have done all this. How much is the quantity shortage? Now let's come to another different type of a question. Sorry. Yeah, so a company is producing sewing machines of type A and B for two different markets, and the two different markets are industrial and personal use, right? It's the same company, but they're producing two different types of sewing machines, okay? Now, both the sewing machines are manufactured in the same factory. If there is a sudden growth in the textile industry leading to a surge in demand for sewing machines of type A, which is for industry, what happens to the supply curve of sewing machines for personal use, which is type B? So type A and type B are two different products which are both being manufactured by the same firm, and they are both using up the same manufacturing space. Somebody's saying shifts to the left. Okay. Other people? Anyone else wants to attempt to answer? I can also say, it is nice if you give a logic for your answer. Why do you think it's B? Why would it be B? So what I mean when I say sudden growth in the textile industry means there is a sudden increase in the demand for type A product, right? So what happens if there's an increase in the demand? There will be obviously much more quantity to be traded. There is going to be, he can also demand a higher price if the demand is, the industry is demanding a whole lot of quantity and there is a very high demand for it, it means that the producer can actually sell a whole lot more and can also make a much more profit because probably he can charge a higher price, right? So what he's going to do is, because the limited space, there is limited space, that's why it's given that they are both being made in the same factory, in the same manufacturing space. Now, if he wants to produce a lot of type A, he has to dedicate that much more space and that much more resources for type A. And hence type B, which is, like less in demand, you can say, or there is a lesser quantity demanded for type B, will have to suffer a little bit, right? Because he has resource constraints here. So in this case, type B is going to be sold much lesser, manufactured much lesser than type A. And if it is manufactured lesser, then obviously it's going to shift to the left, right? Can think of it as a kind of a market shock to the supply curve of type B. Okay, so anybody, any questions on this? No. All right. So let's go to the next question, which is, which is the same continuation of the same question. What is type A and type B in this particular setup? Now, this may not be the universal answer. I'm just saying in this particular question, type A and type B as behaving as complements or substitutes or neither. What do you think it is? You're saying neither. Okay. Other people? Why would it be neither? What do you think it's going to be? It's like a similar logic to what we did in complements and substitutes in the demand side, right? In this particular question, the producer, if the producer was producing X quantity of A and Y quantity of B, now he is producing X plus Z quantity of A and Y minus Z quantity of B. Something like that, right? I'm just giving some loose, expression here, not a whole lot of, nothing complicated. So that means that increase in supply of A is associated with a decrease in supply of B and vice versa. So then it's a kind of a substitute, right? From the supply point of view, from the producer's point of view. It's not a complement, because if they were complements, they would both be, if increase in supply of one would lead to an increase in supply of the other also. But that's not what's happening. So then we see that it's a reverse which is happening. So it's going to be a substitute. Is this making sense? Everyone? Anyone else has any questions? Is this making sense? Yes, no? If you have any doubts about it, you can tell me. Okay, so let's move to the next question. So I'm going to leave you with this question and I will take a 5 minutes break. In the meantime, you can try to solve this question. This is the estimated supply function for avocados. QS is equal to 58 plus 15P minus 20PF. P is price of avocados, PF is price of fertilizer. What happens to the supply curve if the price of fertilizer increases by $1.8? Initially, PF is equal to 0.4, sorry. And you can also illustrate the answer on a diagram. So this is a very simple question, actually. I'll just leave you to solve this, and I will be back in 5 minutes.
Okay. Any success? Any success? Oh dear, what did I do?
Okay, so where were we? Question number. Let me open this screen. Question number 4. I hope you can see my screen. No? Okay. Let's try this again. Can you see my screen? Because I can't. Okay. I think I'll have to disconnect and join again. Yeah. Sorry, just give me a moment. There's some tech issues here. Okay, in the meantime, no. It's not showing my screen, right?
Yeah, I'm sorry about this. It was working perfectly fine. It's not working now. So just give me a moment. I'll just share my screen again.
I think you can see my screen now. Okay. All right. So we were on this question. It's a fairly simple question, actually. So let me just annotate it here itself. So we know this. We know the supply function is given like this. The function is something like QS is equal to 58 plus 15P. P is the price of avocados. And then there is some other factor of minus 20 PF, right? So this is your supply function. And minus 20 PF, like somebody mentioned that it's a substitute, but it's not. I mean, in economic sense, maybe you could think of it that way, but you can't really substitute avocados for fertilizer, right? So from that point of view, it's not really a substitute. Similarly, like you remember in the demand function, we had income also in some of the demand curves, right? And that was just because the demand changes with changes to income, but income is not like a complement or a substitute or something, right? So similarly, you have something like price of fertilizer, and fertilizer is probably here because it's used in growing avocados, right? We're talking about a producer who's growing avocados and who's selling avocados and using fertilizer for that purpose. So as your supply is increasing, if there's an increase in the price of fertilizer, the supplies, you can see just from the function itself, it's minus 20 PF, so the supply is going to decrease. So if the supply is increasing, the supply will shift to the left. If there was a change in P, then you are just traveling up and down the supply curve. But there is another factor, minus 20 PF, in which PF is increasing. That means it is decreasing by minus 20 into 0.4 plus 1.8 is how much? 2.2. So minus 20 into 2.2, so minus 44, something like that, right? It's decreasing by that much. So the supply curve is shifting left. That answer of supply curve is shifting left is correct. It's just not necessarily like a substitute or something. Okay, so let's move to the next question. You have a demand function, you have a supply function. A, B, C, E are all positive quantities or positive constants, and P is the price. So P is not a constant, P is a price. And Q, D, and QS are, of course, quantity demanded and quantity supplied. So you're asked to find the equilibrium price and quantity. And I'm going to leave this question to you to solve. I will discuss this in the next class. And, we will see how many people got the answer. But I think it's fairly simple now. I think it's not so complicated, something you guys can solve. So I will leave this, you can think of it as homework or something, or practice. And I'll discuss this question in the next class again, because it's based on the similar concepts which we have already discussed. That's why. Okay, so question 6 is a little interesting, and it's a little mathematically complex, but that's not the reason why I picked this question. So let's just read the question for a bit. I'll just give you a few minutes to read the question first. So given a supply function, which is log of Q, log the natural logarithm, ln log Q is equal to 0.2 plus 0.55 log P. Okay, where Q is the quantity of processing tomatoes. And so processing tomatoes is something like tomatoes which they are using to make like tomato paste or ketchup or something like that. Okay, and P is the price in dollars per ton. Demand function is something else. it's given as a function of price and PT, where PT is the price of tomato paste, which is what they're using the tomatoes for. It sounds a bit complicated, but it's actually not, because you are just given PT value anyway. PT is given as 102. So this term of 0.15 log of PT, you can just solve it. It just becomes a number which you can add to 2.6. So log of Q is equal to 2.6 minus 0.2 log of P plus 0.5 log of PT, in which case PT is given. Now forget about the log and forget about the PT. What we see here is just a basic demand and supply function. And in this part of the question, this is the first part. You're asked the equilibrium, price, and quantity. So let's solve this. We are given the demand, supply function is log Q is equal to 0.2 plus 0.55 log P. So this is supply, so I'm putting this as QS. And the demand function so you can just reduce the demand function by computing all this. So you can do QD, so 2.6 plus 1.5 into log. So now how will you solve this, assuming you have this number? Does anyone know how to work with logs? What do you do when you have an equation in logs? No? Okay, so this is not the regular way you solve a simple equation. So what you'll do here is, but you can take a shortcut also. You can just equate the quantity and quantity supplied and quantity demanded, and just solve for log P, and then find the value of P. So that is a shortcut for calculating the equilibrium values. Okay, in equilibrium, QS is equal to QD. Therefore, you take the first RHS of the first equation. This is the first 0.2 plus 0.55 log P is equal to this number, which I'll just compute. Minus 0.2 log P. Now you can see that there is, it's just a simple, sort of like a linear equation in P. PT is different from P. Yes. Did I interchange? No, I've not interchanged. This is PT, right? 0.15 log PT. I have just plugged in the value of PT and combined that with the this intercept term. P is still in the same. I'm just simplifying the equation. That's why I'm solving the question. So you understand how to simplify such an equation. Because PT value is given, it's just a little confusing. Actually, even this they have given because these are real equations. They have assessed these equations in some research paper, and they've arrived at these equations. That's why they are looking a bit weird. Real life equations are a bit weird. But you know the price of PT, price PT value, so you just plug in that value and you get this final equation. Okay. So now you have a simple equation kind of a thing in, you have a simple equation in log P actually. So this is 0.75 log P, 2.6. Okay, actually this, 1 minute, this color is wrong. And 2.6, I'm taking 0.2 this side. So this is 2.4 plus 0.15 into log 102. And you can just simplify this. Let me do that. Okay, is this much clear? I've just computed all these values. So if you see what I've done, I've just computed the value of log 102 here. Okay, I plugged in that value 4.625. I've simplified this bracket term and then added it to 2.4. Okay, that's how I get 7.175. It's a little bit rough calculation, but it's enough for our level. Then I've left the left hand side unchanged. So you get 7.175 divided by 0.75. This is the value of log P. Now you have a natural logarithm equation. How do you solve that? You take exponent, right? So you take e to the power of log P, which comes out to be just P, is equal to e to the power of 9.567. And let's hope we are correct. Okay, this is what I'm getting as the answer. Doesn't look like the answer. No, this doesn't look like the answer, and I don't know why. Okay. Let me see if I've made a mistake somewhere. Okay, I don't know where. I mean, I think I'm correct. I have not made any mistake. But okay, let me go to the next part of the question, which is what I wanted to discuss. I think there may be some problem with the question itself, which is not so uncommon actually. But let's come to the question. I wanted to actually discuss the second part of the question. which is that in this, assuming like, say suppose we have the answer to this, we've calculated the equilibrium price and quantity, and I think if I remember correctly, the answer is this. So my answer is not matching this, but I don't know why. I think my method is not wrong. But anyway, let's assume that this is the answer. Whatever the answer is, there's some equilibrium price and quantity, and the equilibrium price is lesser than $85. Now, in this, what happens is that the government is imposing a price support. Price support is nothing but a price floor, right? Price floor and price support mean basically the same thing. When we call it a support, what we mean is that at that price floor, the farmer will want to supply something else, some other quantity, not what we were getting in the equilibrium. So in equilibrium we were getting something like, the price was around $61 or $62, let's say, in equilibrium, and quantity was 11.8, but at $85 the price is much higher, so the farmer will want to supply a whole lot more than what he was supplying before in equilibrium, right? A producer is always happy when the price is more, right? And the consumer is always unhappy when the price is more. So if the producer is now getting $85 per ton, then he is going to want to supply a whole lot more than what he was supplying before. And in that scenario, because that is the case, the government is saying that the government will buy as much as the farmers want to sell at that price, right? So processing firms pay $85. So the buyers are here, processing firms, and they are paying $85. So the market price is $85. So now what we will do is we will compute how much the supply is at $85 and how much the demand is at $85, and whatever is the difference between the demand and the supply, that difference is what the government is going to buy. That is actually what I wanted to explain. Unfortunately, this question was a little bit more complicated in terms of mathematical tediousness. So I'm leaving this question at this point right now, because I want to just solve it again once. I didn't get a time to solve this before the class. So I'll solve this question again, and we'll solve, I'll discuss this again in the next class. But until then, if any of you want to try solving this question, please do. That will be nice. And this slides will anyways be uploaded. So I hope you all got access to the folder last time. I had shared the link to the Google Drive folder. So you did not get any email about the folder yet, right? Where I'm uploading materials or where the videos are being uploaded. Did you get any information about that? Let's share it again. No. Okay. All right. I'm sharing it here again, and it's there in the discussion forum. So it will be good if all of you can join the discussion forum also. There is a Q&A section in the portal, Swayam portal, that takes you to the Google discussion forum. I have posted the link to the YouTube videos and this Google folder where all the slides and notes are getting uploaded. So you can get all the slides and notes after the class in this folder every week. It's the same folder, same link every week. So please use this link and please save it and bookmark it. And it's going to be the same throughout the semester. Hopefully you should get an email also about this, but until then, if you lose it, you can go to the discussion forum. Okay, let's come to the next question. So there's a manufacturer of bicycles, and I've made this a step function. So, he's manufacturing bicycles in batches of 10, let's say. And we have the marginal cost of one batch, which is the same for each bicycle in that batch. So for bicycle number 1 to 10, marginal cost is 4,000. For 11 to 20, it is 4,200, and so on and so forth. So the table is giving you the marginal cost for producing the ith bicycle. which means that the marginal cost of bicycle 1, bicycle 2, 3, 4, 5, 6, 7, 8, 9, 10, for each of those, marginal cost is 4,000. So I made it into a step function like what you have in the lectures. Now, if the market price of a bicycle is 5,700, how many bicycles will the manufacturer sell? So I'll give you a few minutes to think. Anyone? $50, okay. Others? Anybody else? Anyone else? So what is the condition for selling any product? We discussed this in the class so far. The market price needs to be more than or equal to marginal cost, right? That is the condition for any producer selling anything, right? So you can see that only up till the 50th bicycle, the marginal cost is less than market price, which is market price is 5,700 and marginal cost is 5,500. So only up till the 50th bicycle will this guy be making any kind of a profit, right? He's not going to be making any kind of profit on the remaining bicycles, because from the 51st bicycle itself, the marginal cost is now 5,800, which is more than the market price, isn't it? So he's not making any kind of profit from the 51st bicycle or 52nd and so on and so forth. Only up till the 50th bicycle, there is some positive profit, which is, we can say it's like 200 rupees per, per item for the 41st to the 50th bicycle. And for the 31st to 40, it is more. For that, before that, it is more. So you can compute it that way. But what is the, there is no way he can sell more than 50 though, because at the 50th bicycle, he's in the next batch, he's not going to be making any profit. Is this making sense? Only one person has answered, so that's why I'm having doubts. Okay, is this okay? Yes, no, maybe. Okay, so the next question is a continuation of this same question. So in this question, in the same setup, if a typical buyer is willing to buy the cycle for 6,000, what is the total consumer surplus and the total producer surplus? Does anybody want to answer? Say the maximum willingness to pay is constant for the consumer. Okay, let me write this down. So price is 5,700, maximum willingness to pay is 6,000, and we just found that producer will sell only 50 bicycles, right? Because beyond 50, he does not make any profit. Okay, so we know that quantity Q or Q star is equal to 50, and on each bicycle, consumer surplus is equal to 6,000 minus 5,700, 300, right? So on each bicycle, because you are willing to pay up to 6,000 bucks for the bicycle, but the bicycle is costing only 5,700. That's the market price. So on each bicycle, you're making, the consumer is making 300. And how many bicycles are there? 50. Therefore, total consumer surplus is 50 into 300, which is 1,500. So you said 300. 300 is the consumer surplus for each bike. On each bicycle, you're making 300 surplus. And how many are there? 50 are getting sold in the market. Hence, you're getting 1,500 as the total consumer surplus. Now let's come to producer surplus. We want to talk about producer surplus also, right? So now let me just draw that diagram. Yes, 15,000. Yes, you're correct. Okay, so it's 15,000, not 1,500. Sorry, my bad. Now let's see what the marginal cost is for each batch of bicycles. I'm making that same diagram. Just from horizontal, I'm making vertical. From 1 to 10, marginal cost was 4,000. And let's make another column here. This is becoming very untidy. Okay, so let's go one by one. Okay, after 50, there is no sale, so we don't need to write that part. This is marginal cost is 4,000. This is 4,200. This is 4,500. This is 5,000. This is 5,500. So each batch is made up of 10 bicycles, right? And how do we take the producer surplus? It is the market price minus marginal cost. Let me make this column a bit bigger. So market price is 5,700 and marginal cost is 4,000 into 10. This is not needed actually. So this comes out to be 1,700 into 10, which is 17,000, right? Similarly, you can compute the others. 5,700 minus 4,200 into 10. 5,700 minus 4,500 into 10. 5,700 minus 5,000 to 10, and 5,700 minus 5,500 into 10. And whatever this comes out to be, you take the sum of that, and that is your total producer surplus. So this is this is 12,000. This, no, sorry, 15,000, not 12,000. This is 15,000. This is 12,000. This is 7,000. This is 2,000. Now you take a sum of all of these, whatever that number comes out to be. That is your total producer surplus. Make it a bit better. Summation of all of this, which is whatever it comes out to be. You can compute that. Okay. So is this okay? Is this clear? How we computed the total producer surplus? Because the marginal cost is different for each batch of the cycles, we have to compute it separately for each batch, right? Now, this is the same thing we are doing when you're taking the area of the triangle, but in the area of the triangle, it's not a step function. Like this is a step function. The area of a triangle is not a step function, and that is why we can just directly compute it as a area and not, we don't have to do all this summation thing and all. In this case, we are doing exactly the same thing, but we have to take a sum of each step, basically. Okay, so I think this is it for today. I had actually anticipated spending more time on question number 6, but somehow the answer is kind of wrong. So I will recalculate, and question 6 is not the kind of questions you're going to be getting. So please don't worry about it. I don't think you will get questions with log and stuff in your assessments or your exams. It's actually a book from the same level of difficulty as this course, but well, you don't have to worry about that question, but I wanted you to understand the concept behind price support and minimum support price or price floor, all of that. So I hope that is clear. The calculation part, we can redo it in the next class. So is that part clear for question 6?
That
What
part,
is price support?
could you go through
Yes.
that part once again? The price floor one, it was new for me.
Okay. I will explain it again, but I would really want you to ask me a question when I'm answering or explaining that question at that time. I mean, I don't mind explaining again, but when I'm explaining and when I'm asking if it is clear, it is good if you tell me then itself, because then I can again explain it more easily. Isn't it? So we're here, what we are saying is that the price, oops, what happened? Okay, so the price in equilibrium is something else. Say, suppose let's assume the price in equilibrium is $60. Okay, let's assume that equilibrium price is $60. Now we are saying that price support is $85, which means that there is a price floor. Price floor is when you cannot lower prices beyond that price. The government has set that price, and that is $85, which means government wants the price of tomatoes to be $85, which is much more than the equilibrium price. Now at $85, the farmer wants to sell a whole lot of tomatoes, but the firms who are buying the tomatoes, they don't want to buy as much, right? So there is going to be an excess in the supply. You understand that? There's going to be excess in supply. You'll have extra supply than what you can clear in the market. In the market only, at $85, the firms don't want to buy what they were buying initially. If initially they were buying 15 ton, let's assume initially they were buying 15 ton, at $85, they will only want to buy something much lesser, maybe 6 ton, 7 ton, something like that. So there is a huge excess supply when there is a price support. And the government has said that they will buy as much as farmers want to sell at that price, which means that, whatever the quantity farmers are willing to supply at $85, that is, like we said, it is much more than the quantity demanded. So there is a difference. That excess is what the government is willing to buy. So when you compute the new quantity demanded and the quantity supplied at $85, you take the difference between the two. So the quantity demanded is what the buyers are going to buy, and this excess, this difference between QS prime and QD prime is what the government is going to buy. So that is all there is actually. That's the question. How many tons do the firms buy and how many does the government buy? Is this making sense now?
Yes, madam.
Okay, great. So then I will end this class here and I will come back to it. There is one question I left as an exercise, this one. So this is a simple algebraic expression. I will upload the slides and please solve it. It's just an algebra question. That's why I didn't solve it in the class. And we will discuss it in the next class. And this question, I will redo the calculation and we'll discuss it again in the next class.
Excuse me, ma'am.
Yes.
In that fertilizer and avocado question,
Yes.
after seeing the equation, why we can't say that avocado and fertilizer are substitute to each other?
Can you eat fertilizer instead of
Yes, ma'am,
avocado?
that's not practically true, but from
No,
that
it's not
question,
practically true because they're not being used as substitutes, right? So there can always be other functions or other, not functions, but other terms in a demand function or in a supply function, which are other than just substitutes or complements. Like in your demand function, you can also have income, you can also have price of some other product, you can also have price of some input material. So in this case, fertilizer is not a substitute or a complement, it is an input for avocados. And this is what we have right now, is a very simple, kind of a setup where we are just writing very simple demand and supply functions. We're not actually going into the nitty-gritties of why is it like this or why is it like that. But in general, in a supply function, you will have a cost term in a production function, not supply function, but a cost term is generally there in a production function. And when we come to producer theory, that part will probably become much clearer to you. Right now, we are not doing producer theory. That's why I think it's difficult to internalize what this is. But when we do producer theory and we compute supply function, is nothing but marginal cost, right? So marginal cost function can have other terms also in it, which are input material. So in this case, this is a supply function where the fertilizer is coming up, right? So in this case, fertilizer is an input for avocados. You understand? You need it to make avocados basically. But
yeah,
if the price of an input material is increasing, obviously your cost is increasing. So, your supply is going to be much lesser. Your raw material price is increasing basically. Does that make sense? I know it can be a bit confusing, but it's not technically a substitute or a complement in this case. It's an input material. Okay. Okay, I don't know if there's a problem with your audio or if you're still thinking about the answer. So, any other questions?